record, maximize. All right, so we're gonna pick up where we left off. The last thing we did was dividing polynomials. So today we're gonna probably do what looks like the second half of the semester. So what I want you to do here, or what I'm gonna do for you, just to get warmed up, is we're gonna simplify this expression. All right, and it's gonna be x to the third plus 6x squared all over x squared plus 2x minus 24. Can you believe that this is our last class? This is it. This is it. Can't believe that. We've had such a great semester together. Even though it's been on Zoom, it's still been pretty good. At least I thought so. What were you going to say, Crystal? I cut you off.
I said thank you for that semester.
You are very welcome. All right, now, first things first. What type of expression is that? What type of expression is that? Well, if you look at it, you have a polynomial in the numerator, polynomial in the denominator. So it is starts with an R. It's a rational expression. And when we simplify rational expressions, what is the key thing to do? What is our key? What is that one thing that we definitely want to do? Love it. Thank you so much. All right, so we're going to factor everything. So I look at a numerator. Hopefully you have that factoring sheet, okay? So you want to look for a GCF. That's the first thing. So in the numerator, I could definitely factor out x squared to give me x squared times the quantity x plus 6. Second, there's nothing else I can factor there, so I'm going to move on to the denominator. Now, there's no GCF there, and that's okay. I have 3 terms, so it's a trinomial with a leading coefficient of 1. So I'm going to go directly into this. Then I copy down my x. I always copy the first sign down. The second sign has to be a minus. So directly underneath, I'm just going to write out the factors. Three and 4, that's wrong. 3 and 8. There we go. And I know one of these factors will be positive, one's negative. And they have to combine to give me a positive 2. So that's going to be negative 4 plus 6. So now that I factored everything, I just look for terms that are the same on the top and bottom. So the x plus 6's will reduce to yield x squared over x minus 4. Okay, any questions there? All right, now here's one for you. So I did a really easy one, and now I'm just going to throw you in the deep end. So I hope you remember how to swim. AKA, I hope you remember how to factor. All right, so go for it. It's going to take you some time. Does anybody need any help? Are you okay? All right. Okay, we ready to go over this? This one's a biggie.
I got 5n minus 40 over 6n square positive 13n minus 5.
Is that
Sure is correct.
is that your final answer?
Yes.
Okay. Say it one more time.
5n minus 40 over minus 40.
Oh, minus 40.
Yeah.
Oh, well, that's not completely factored then.
Over 6n square 6n square positive 13n minus 5.
Okay. All right, I'm not saying that's correct or not, but we're going to go over it, okay? Everybody looks like they're still working. We'll give it a minute. All right, you guys ready? Yes, no, maybe so. All right, let's go over it. So, first thing I'm going to do, I make sure everything is in descending order in terms of the polynomials, and that's the way they look, so that's good. I am dividing, which means I need to rewrite this as the first fraction stays the same, or the first rational expression. I will change division into multiplication, and then the reciprocal of the second fraction. Now, I just got to factor everything, and I'm going to keep it simple. So, the 20n squared minus 125. You look for a GCF first. I can factor out a 5. That's going to give me 5 times 4n squared minus 25. But if you look here, that's going to be the difference of squares. So this turns out to be 5 times 2n plus 5 and 2n minus 5. So that entire numerator there, actually, you know what? I'm going to write it all the way down here. So there's our first factoring, or our first numerator factored. Now, here's what I'm going to do. I'm going to change it up a little bit. I'm going to go over to the next fraction because that numerator is really easy for me to factor. There's no GCF, trinomial with a 1 as a leading coefficient. Both signs are going to be negative, so I just need 2 numbers that multiply to give me 56 and combine to give me negative 15. And that's going to be n minus 7 and n minus 8. Now, here's the reason why I decided to do that. I know in both denominators, they're trinomials. I don't see a GCF for either. And more importantly, the number in front is not a 1. It's something different. I'm going to use that to my advantage when I factor. In other words, now that I've factored all my numerators, when I go to factor my denominators, it's going to actually help me a little bit to factor. So let's see, what do we have here? Draw a line. 2n squared minus 19n plus 35. So I know I got to do the AC method. So let's get an idea. N minus, so that's pretty good. 2 times 35 equals 70. So now I need the factors of 70. Excuse me, 1 and 70. 2 and 35. 3 doesn't work. 4 doesn't work. 5 definitely works. 5 and 14. How about 7 and 10? And I need these to combine to give me negative 19, so it looks like it's going to be right here. So I get 2n squared minus 5n minus 14n plus 35. So I don't know about you, but I'm already seeing something that I can reduce, which is going to be right there. Like I know I can already reduce that because I can see it actually starting to appear. What I mean by that is when we go ahead and factor by grouping here, remember, there's a negative in the middle, so that second sign has to change. I can factor out an n out of the first term, or first grouping, and a 7 out of the second grouping. So what's that going to be? 2n minus 5. So you can already see the 2n minus 5, which is what I'm pointing to right there. You know that's going to reduce, and that's going to help us out tremendously. So I'm going to write n minus 7 and 2n minus 5. So that was pretty nice. I like that. Makes it easy for me. Also, it's kind of, it built some confidence in you because you could start to see, oh, I know that's going to factor. I must be doing something right. Like, I got to be on the right path. So I factored that denominator. Now I'm going to factor out the second denominator. I'm going to erase all my factoring on the right-hand side. Is that okay? All right. Crystal, that was a big yawn. Just think. Just think. You after our final next week, you don't have to wake up early all summer. Unless you get a job or something like that. All right, so 6n squared plus 13n minus 5. Remember, no GCF, trinomial. A is different from 1, so factor by grouping. I'm sorry, AC method and then factor by grouping. I'm just going to get an idea. 6 times 5 is 30. So that's going to give me 1 and 30, 2 and 15, 3 and 10, 5 and 6. I know of this pair, 1 is positive, 1 is negative, and they have to combine to give me positive 13. So negative 2 plus 15 equals positive 13. So that's my pair. So I'm going to rewrite it as 6n squared minus 2n plus 15n minus 5. Now I'll group 6n squared minus 2n plus 15n minus 5. So my GCF for the first grouping is going to be a 2. That was weird. Okay, going to be a 2n. So that's going to give me 3n minus 1. For the second grouping, I can factor out a 5. So that's going to be 3n minus 1 again. So when everything is all said and done, it's going to be 3n minus 1 times 2n plus 5. All right. So now that the hard part is over, we can go ahead and start reducing things. So we just look for terms or groupings that are the same in the numerator and denominator. So that's going to be, let's see here, the 2n plus 5, that reduces. The 2n minus 5, that reduces. The n minus 7s, they reduce. And that looks about it. So when everything is all said and done, your final result is going to be 5. Or I'm sorry, the numerator. It's going to be 5 times the quantity of n minus 8. And I'm typing this in because I forgot to show you this the other day. I want to make sure everyone knows about this. I think you already do, but I need to go over it. Over 3n minus 1. Okay? So real quick, before we move on, I just wanted to show you this. Because I was talking to my MAT090 students about this. They got a little nervous about the final, really. So anytime you type in an answer, all right, and you hit the enter button or you hit this arrow button over or something like that, number one, the test will automatically save that answer. And another thing you'll see is, what question is this? What number? Oh, 13. Okay, so when I go on to the next one, Notice on question 13, there's a little gold circle right there. What that means is you've already answered that question. It doesn't say if you're right or wrong yet. It just says you've answered it. The reason why I'm telling you this is the final. It covers the entire semester, okay? I think your final has 36 questions on it, just like this. I would much rather you answer 30 questions that you know how to do versus 20 questions where you spent 25 minutes on one problem. In other words, if you don't know how to do that problem right from the start, skip it. Just go on to the next problem. Before you submit your test, you click this arrow down in the middle, and it'll tell you which ones you answered and which problems you didn't. So then you can go back and do the ones that you didn't do. Does that make sense? This final is not, how do I want to say this here? There are no curveballs. These questions are going to be the middle of the road questions. They're not going to be overly difficult. They're not going to be super easy. They're really going to test you. Do you know what you're doing? So if you think about the factoring that we did here, none of that factoring was really overbearing. It really wasn't. But it really tests. Did you, like right here, this is the biggie. For me, this was the biggie right here. Did you recognize the difference of squares there after you factored out your GCF? Like, I don't know. Maybe some people in the room didn't see that. That's what this is about. That's not a curveball. That's a difference of squares, and that's something we need to know how to do. Okay? Are there any questions? All right. Let's move on then. So here's another problem. Now this one's going to be, obviously we just saw multiplying and dividing a rational expression. So you better believe I'm going to put an adding or subtracting one on here as well. So we have 2 over x plus 1, x minus 1, plus 7 over x plus 1 to the second power. So first, I'm adding rational expressions here, which means I need a what? Common denominator. Excellent. So the first thing I'm going to do is, remember, I always factor. I try to look for factoring. Now, this problem is almost completely factored. I'm going to rewrite it. The first denominator, that's good. It's the second one. And let's be honest, x plus 1 to the second power, we should know what that means. That means x plus 1 times x plus 1. So now I can go ahead and try to find my LCD real fast. And my LCD is going to be the product of unique factors. So x plus 1 and x minus 1, because they're different. And also I need to worry about, is there an exponent on either one of these factors? And in this case, the x plus 1 will be raised to the second power. Or you could just write this as x plus 1 times x plus 1 times x minus 1. Personally, no matter what, I always rewrite it like this. That's just me, though. Now, are there any questions about how I arrived at my LCD? All right. So I'm going to multiply by some fraction. Let me just write this real fast so I can talk to you. Here's what we know. We're going to multiply both rational expressions by the number 1. We're going to be really clever on how we write that number 1. Also, we need to make our denominators look exactly like the LCD. So in that first rational expression, the 2 over x plus 1, x minus 1, this is where I come in and I do like the little check mark thing. In other words, I see an x plus 1 in the denominator of the first rational expression. So that means I have an x plus 1 in my LCD. Those two things match. I also have an x minus 1 and an x minus 1 in the LCD. I'm missing another x plus 1. So that's what I'm going to multiply this first rational expression by. So it's kind of like the matching game. You just match up what you have, and then you give the rational expression what it doesn't. So for the second rational expression, we have two x plus 1s. It needs an x minus 1. Okay? Now, this is just me. I will rewrite this with just one denominator. And I'm going to rewrite the entire numerator exactly how it looks. No simplifying yet. Can anybody tell me why I did that? What happens if this is a minus sign? What do I not want to forget? Say it again, B. I'm sorry, I didn't hear you. Yes. Yes. If this is a minus, if this happened to be a minus, I don't want to forget to distribute that. That is why I take this little intermediate step. All right? It literally took me 25 seconds to write it. Don't get lazy on me now. Just write it out. All right. So in the numerator, that's where all the work is going to happen now. I got to distribute 2x plus 2 plus 7x minus 7. I need to group like terms. 2x plus 7x is going to be 9x. 2 minus 7 is negative 5. And before I circle my answer, I always ask myself, that numerator, 9x minus 5, can it be factored? The answer is no, this cannot. So, I know I'm done. All right, any questions? All right, now there are two things that you're definitely gonna want to remember. And you should have that factoring flow chart to help you. So I'm going to write, don't forget difference of squares and the sum slash difference of cubes. All right? Because you were totally going to see them. So real quick, here's an example of each. Now, remember, you look for a GCF first. In this situation, there isn't one. So then, you count the number of terms. We have 2. So this is a binomial. Now, the variables kind of tell you what you're looking at. Since it's x to the second power, I know this is going to be, hopefully, the difference of squares. Difference means subtraction. I definitely have that in the middle. So I have the difference of squares. So I know it's going to factor down into 2 binomials. One's going to be plus, one's going to be minus. The only thing I need to worry about, what are the terms? Well, what number squared gives you 169? Does anybody remember? 13. So that's going to be 13 squared. And what number squared gives you 121? 11. Good. Actually, I don't need the squares there because I wanted to do this. So this is going to be 13x plus 11y and then 13x minus 11y. And that's it. That's as hard as that got. So here's our second example. All right, so we have 5x to the third minus 40. Okay? So always look for a GCF. In this situation, there is one. So I'll factor out a 5. Now, inside the parentheses, you have two terms with a minus sign in between. And remember, the variable tells you what you're looking at. Since this is x to the third power, I'm thinking the difference of cubes. Now, you should have that sheet with you because that gives you the formula. I'm going to write the formula over to the right in red. A cubed minus b cubed equals SOAP. And that's how I remember it. SOAP, you wash your hands with it, and SOAP also stands for, if you're looking at the screen right now, the same, opposite, always positive, which means the signs are the same, opposite, always positive. I'm dorky. Luckily for you, you don't have to memorize the formula because you have it. So for us, our problem is going to equal, now remember, you have a 5 out front. Don't forget that. That is going to be an x. That is going to be a 2 because 2 to the third power is 8. So, x minus 2 times a quantity, x squared plus 2x plus 4. Are there any questions? All right. So let's just continue now. Now we're going to get into some solving things, okay? So we have 7 times a quantity, 2n plus 5 equals 7 times a quantity, 4n plus 5, and then plus 9 on the outside. Before I even start, what do you think the first question I ask myself is? Now I'm asking you to think like me, which is scary. So what do you think the first thing I look at in this problem is? Amanda, what do you think? I haven't talked to you in a while. Uh-oh, no Amanda. All right, Hannah, what about you?
The next step.
But in order for me to do the next step, I got to know what type of problem I have first, correct? So that's the first thing I look for is what type of problem do I have? And what I mean by that, is this problem linear or is this quadratic? Because if you really, really take a step back, we have a set of steps for linear problems, and then we have a set of steps for quadratic problems. What type of problem is this? I disagree. So obviously, Hannah, if it's not quadratic, it must be what? And why is it linear?
Because it doesn't have any exponents.
Well, it does. The exponents are what specifically?
1.
And that's what makes it linear. So now that I know it's linear, I'm thinking step 1, if I see fractions, multiply by an LCD to eliminate all denominators. No fractions. Step 2, if I see parentheses, distribute to remove them. So I get 14n plus 35 equals 28n plus 35 plus 9. Step 3, I look on the left and only the left. And I ask myself, can I group like terms? The answer to that is no. So then I look on the right and I ask myself, can I group like terms? That answer is yes. So I get 14n plus 35 equals 28n, and then 35 plus 9 is, 44? Is that correct? Step 4. Now this is where I want to get variable terms on one side, constant terms on the opposite side. So I'll subtract 14n from both sides. I'll do that first. So that's going to give me 14n plus 44. Now I will subtract 44 from both sides. I think you get negative 11. Is that correct? No. It's negative 9. And then my last move, step 5, divide both sides by the number in front of the variable. Okay? So this entire problem all started with a simple question, and that question is, what type of problem do I have? And the answer to that was linear. You should also have those steps for solving linear equations written in your notes somewhere. I think it's what, chapter 10? Yeah, chapter 10, linear equations. So I know they're in there. All right. Next problem. We're solving again. Hannah, I'm going to give you a chance to redeem yourself. What type of problem do I have here?
It's not linear.
So if it's not linear, what is it? Yes, it's quadratic. That, remember, you look for the highest exponent, and that's going to be your technique. So since this is y to the second power, it's quadratic, which means I have another set of guidelines. I have another set of steps to do. So when I'm solving quadratics, what's my first step? When I'm solving quadratics, I'm sorry, Ramzi, I cut you off.
Mirror the equation equals 0.
Set the equation equal to 0. I love it. So I'm going to subtract 30y from both sides. Now, before I move any further, I'm going to zoom out here because I want you to see the difference here. In the previous problem, we determined it was linear, which meant step 1, we look for fractions. Step 2, we do parentheses and stuff. In the second example, this is quadratic. I set it equal to 0. Do you see how different those methods of solving are? It's all about what type of problem do you have. So, now that I set it equal to 0, we factor. And we know how to factor. You always look for a GCF first. So with this problem, I could totally factor out a 5y. That's going to leave me with 5y minus 6. Now, I set each variable term or each variable factor equal to 0. So, 5y equals 0. 5y minus 6 equals 0. And I solve these. In the first, I divide both sides by 5. I get y equals 0. And then for the second solution, I add 6 to both sides. That gives me 5y equals 6. Then I divide both sides by 5 to give me y equals 6 over 5. To type in your answer, MyMathLab, they're going to give you the squiggly braces. The only thing they're going to say is type in your answer, use a comma to separate them. So you would just literally type in 0, comma, 6 over 5. That's it. Are there any questions there? Okay. Here's our third type of problem that we examined this year. This is an absolute value equation. So to solve an absolute value equation, the first thing you need to do is isolate the absolute value. Our problem, already isolated. I like that. Now, in order for me to apply the rule for the absolute value, I need to check that number right there. And what's so important about that number? What does that number have to be?
-5.
No. Ramzi, you're just moving too fast. In order for me to apply that property that we learned, that how do we solve absolute value equations? Remember, there was an if-then statement. That number on the right-hand side, that number opposite the absolute value symbol, has to be what sign? What type of number? Got to be positive. Thank you, Jada. So, because this is positive, I know I can move further. So, I'm going to rewrite this as 2x minus 1 equals 5, or 2x minus 1 equals negative 5. All right? Now, from here, I just go ahead and solve each problem independently. So I add 1 to both sides. That's going to give me 2x equals 6. Now I divide both sides by the number in front to give me x equals 3. For the second, I add 1 to both sides. I get 2x equals negative 4. Then I will divide both sides by 2 to give me x equals negative 2. All right, are there any questions? So if you think about it, so far we've already examined 3 different types of problems that we actually encountered this semester. Linear, quadratic, absolute value. Here's the fourth. So we have 8x, excuse me, 8x over x plus 3 minus 8 equals, did you guys hear him? He just barked. So equals x minus 14 over x minus 3. Now, from the very start, what is the first thing that I'm looking at? That would be the second thing I looked at. You're correct, though, Jada. Like, I'm definitely going to do that. I know x cannot equal -3 or 3 for possible solutions. Because remember, I look at those denominators and I see the variable. So all I did in my head was I set each one of them equal to 0, and I solved. And I said, okay, if I come up with -3 or 3, I know I'm not allowed to have that. See here. Let me go back. Sorry. Here's the problem right here. You may run into the situation where there is no solution to this problem. How do you know that? Because you're going to have to do all the work. And once you get to the very end, if one of your answers happens to be -3 or 3, you click no solution and next. But you're not going to know that unless you check your answers. So by me starting this at the very beginning, it's kind of like me already checking my answer. So now we're going to go with exactly what Jada said, which is we need to find that LCD. Because remember, I see fractions, so I want to multiply by the LCD to eliminate them. The LCD is going to be the product of unique factors. In this case, it's just x plus 3 times x minus 3. So, give me 1 second. I'm going to write this nice and neat. Guess I didn't need brackets at large. Now I multiply every single term by my LCD. And my goal is to remove those denominators. So if I go left to right, notice I have an x plus 3 outside and an x plus 3 in the denominator. So they reduce. I write what's ever left over. 8x times x minus 3. Minus. Now in this second part in the middle, nothing reduces. So I'm just going to rewrite it. X plus 3 times the quantity x minus 3 times 8 equals. Now on the right hand side of the equation, x minus 3 in the numerator, x minus 3 in the denominator. And I write everything else exactly how it looks. X plus 3 times the quantity x minus 14. Now, initially, everything in this problem, all the x's are raised to the first power. So it kind of looks like that this is linear. But as soon as you simplify, watch what happens. I need to distribute. I get an 8x squared minus 24x. Now, in this middle part, x plus 3x minus 3. I know that is the sum or difference of squares. So that's going to be, and I'm going to do it off to the right here so you can actually see it. X plus 3 times x minus 3 is x squared minus 9. Now, you could put the 8 around front, because remember, multiplying order doesn't matter. So that's going to give me 8x squared minus 72, because I had to distribute the 8. So 8 times x squared is 8x squared. And 8 times -9 is -72. But I have a mistake here. I got a mistake. Anybody see my mistake? Before I correct it? Because I definitely have a mistake here. All right, here's my mistake. It's minus this entire middle part, which means what I should have done on the far right side, so let me fix it, is I should have put a -8 there to give me negative x squared plus 72. So there's my mistake right there. All right, now on the right-hand side, let's go ahead and distribute. So you get x squared minus 14x plus 3x minus, what is that? 3 times 4 is 12, 42. And that's going to give, let me write it in black, x squared minus 11x minus 42. How are we looking so far, everybody? This one's a little bit of a doozy. So now, I see the x squareds. I know this is quadratic, which means I'm going to set it equal to 0 and solve. But what I'm going to do is group everything first on the left and group everything on the right that I can. 8x squared minus 8x squared. They cancel each other out. That's a good thing. So I'm left over with negative 24x plus 72 equals x squared minus 11x minus 42. So it's still quadratic. So I'm still going to go ahead and set this equal to 0. So I just take my time. I'm going to group the x's together. So negative 11 plus 24 is 13x minus 42. Now I'm going to subtract 72 from both sides. So negative 42 minus 72 is 114. Boy, I really hope I didn't make a mistake somewhere. What do you guys think? I mean, my math, I'm going with it, so. So I'm going to factor, plus and a minus. Now I need factors of 114, and this is going to be just a pain in the butt. So here's what you do. I'm going to make it easier for us. Come on, where'd you go? Ah, there you are. Just get a calculator and just start dividing by numbers. So 2 and 57. 3 and 38. I don't know if a 4 works. What did you get? 6 and 19. I'm going to go with that. So, negative 6 plus 19 equals 13. And that's good. So, 6 and 19. So, I set each one of these equal to 0. X equals negative 6. And x equals 19. And I know from here I don't have to worry about excluding solutions or anything like that, because neither problem was 3 or negative 3.
Isn't it should be the opposite way?
What do you mean? Did I not? Oh, I did. I put them in the wrong spots. Thank you, B. Should be plus 19 minus 6. So the answer is negative 19 and positive 6. Thanks, B. My bad. All right. So we're almost done. Couple more examples. If I just give you a equation and I say solve for a specific variable, all right, what you're going to have to do is know how to do that. So I'm going to solve for x. So the x is being multiplied by the d. So this fy, I'm going to move to the other side. So all I'm going to do is just rewrite real quick. Subtract the fy from both sides of my equation. That gives me dx equals k minus fy. And then divide everything by the value in front of the variable. In this case, it's a d. To give us x equals k minus f times y divided by d. Okay, are there any questions there? All right. So let's move on. We're going to solve and write the solution in interval notation. And here's our problem. So it's 4 times the quantity, x plus 2, minus 3x is greater than or equal to negative 4. And remember, we want the solution in interval notation. So this is linear. We treat it like it's linear, which means I'm going to distribute. I look on the left and I group my like terms. 4x minus 3x is x plus 8. Is greater than or equal to negative 4. Then I subtract 8 from both sides to give me 8 is greater than or equal to negative 12. I take 1 second and I graph it. Since I want values of x that are greater than negative 12, it's a bracket that goes to the right. So my set interval notation is bracket negative 12, comma, infinity. Okay, so far so good. All right, so for this, I'm going to have to just drag this over because I want to make sure that we remember how to do this. So graph the linear equation by finding and plotting its intercepts. So let's see, the answer, or I'm sorry, the equation is negative x plus 5y equals 10. So let me go ahead and write that first. Get out of my way. So negative x plus 5y equals 10. Now remember, they want us to use intercepts, and at an x-intercept, y is always 0. So this is going to be negative x equals 10. Now, don't get lazy. Negative x equals 10. You need to divide both sides by negative 1. So our first intercept is negative 10 comma 0. Okay? Now, at a y-intercept, our x value is going to be 0. So this is just going to be 5y equals 10. Therefore, we divide both sides by the number in front. So 10 divided by 5 is 2. So my second intercept is 0, 2. Now, just so we remember, click to enlarge the graph. You're going to use the line segment tool. And you're just going to click on those points. Negative 10, 0 and 0, 2. And remember, in the upper right-hand corner right here, they're going to tell you what your point is. So when you move it around, you know exactly where you are. Okay? Then you just click on save, and it'll just save your answer right there. All right? Now, the next one, super easy. Y equals negative 7. What type of graph is that? We know it's a line because the y is raised to the first power. The question becomes, is it a slanted line? Is it a vertical line? Or is it a horizontal line? And where is it?
The line through the x-axis.
I disagree.
The y.
Through the y-axis?
Well, it's gonna be like.
Okay, so what is that? What is this, Crystal? Is that vertical or is it horizontal?
Horizontal.
There you go. And it's horizontal at y equals negative 7. So you go down to y equals negative 7, which is right there. Click on it. And since you know it's horizontal, it doesn't matter if you go to the left or if you go to the right. What matters, that line better be flat. Better be horizontal. If it's like that, it's wrong. So it doesn't matter where you click. Just pick a spot. We're looking for a horizontal line. Does that make sense, everyone? All right. So I will tell you this. You will have 1, 2, 3. You're going to have 2 word problems. Okay? And then for some reason, and I can't for the life of me, I think we did, but I'm going to show you this anyways. This problem right here, you're going to see this problem. All right? Right, B. I like the face you just made. All right? So this says, graph the linear equation in 2 variables. Using the different range settings given, determine which settings shows all the intercepts of the line. Okay? So when it says all the intercepts, the first thing that we need to be thinking of is this. You want to make sure that you can see the x and you can see the y-intercept, okay? That's the first thing. Now, here's what they're talking about here, okay? They're saying setting A and setting B. So setting A, in fact, let me do this. Sorry, just bear with me real fast. What is this? MAT090 SC04. Sync the notebook now because I want this. Is this SC04? Yeah, this is SC04. Okay, so here we go. No, compound inequalities. Where's my review? It's in blue. Come on, give me the blue. All right, well, it doesn't matter. So here's what I'm just gonna go with it. All right. So here's our problem right here, okay? Oh, no. Now this needs synced. See, I need to be able to write is what I need. There it is. Okay, okay. Give me 1 second. Whoop. All right. I got way too many. I have too many mice, all that stuff. Here we go. I can write X, Y. That's what those mean. So, for example, in setting A, the X is going to go from -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes from -10 to 10. And then the Y values go from negative 10 to positive 20. So all the way down here is going to be -10. And all the way up here is going to be positive 20. The only thing they want to know is this. If you were to graph this, okay, what setting would you use? Now, you don't need a graphing calculator for this. What this is really asking you is, do you know y equals 3x plus 27? Do you know what that actually is? Now, don't forget, this is y equals mx plus b, where m is going to be the slope, and 0, comma b is that y intercept. Does that make sense, everybody? Yes or no so far? Okay? Now, in this situation, our slope is 3, and our y-intercept is 0, comma 27. Does everybody agree there? So, if you look at setting A, notice your y values only go from -10 to 20. Your y-intercept is 27. So would you see the y-intercept in that window? Shake your head, B. Shake it emphatically. Now explain to us why. Yeah, this window only gets you to a y value of 20. You need a y value of 27. See, that's what this question is asking you. Do you understand that you have y equals mx plus b here? Okay? So, obviously, if it's not letter A, it has to be this setting right here. In fact, let's even do this. Notice that regardless of setting A or B, your x values are the same, -10 to 10. The difference is in that y value. So the only setting that you would see the y-intercept here is in setting B. All right? So it's just another way of me asking, what's the y-intercept? Where would you see it? Does that make sense, everyone? Yes or no? Oh, sorry. Yes or no? Are we good? Okay. Well,